Hi there, Mr. Sutton here with the IM376 Extra Practice number 1 solutions on law of sines. For this problem, trying to find an angle in a non-right triangle, since I do know a side and an angle that are across from each other, I'm going to use the law of sines for this. Sine of A over A equals sine of B over B. So let's start with the angle side pair that I've got constants for. We have sine of 80 over 21 equals, now we have the sine of the x angle that we're missing over the side that's across from that, which is 25. So now I'm going to have to get sine of x by itself, and then I'll do something else. But let me start by multiplying both sides by 25. So I can write sine of x equals 25 sine of 80 over 21. And then to actually get x, I have to do sine inverse of all this craziness on the right. So let me do that on the calculator now. So here I am on the calculator. I've done second sine to get sine inverse and alpha y equals to give me my fancy fraction. Now pressing enter on all that stuff, it says error. So this is telling us that x actually does not exist, is undefined. And what that means is that the triangle they gave us here, which they never claimed was drawn to scale, this triangle actually can't exist with these dimensions. So there is no such triangle that meets these conditions. Basically, the problem is undefined and we're done. For this problem, I'm trying to find this missing side. Now, this is not a right triangle. This almost looks like a right triangle, but they never said that this was 90 degrees. And in fact, if you add these two angles together and subtract it from 180, you'll see this is not, in fact, 90 degrees. It's pretty close, though. So the key to actually doing this problem is to figure out what this third angle is. So if we have, let's see, 45 plus 43, that's 88. Subtract that from 180, and that is going to be 92. So almost 90 degrees. Now that we actually have this angle, what we have here is an angle and a side across from it that we know both of them. So although it's not a right triangle, we can still use the law of sines since we have this angle side pair now to figure out whatever else we need. So let me do law of sines. That's sine of A over A equals sine of B over B. Let's start with the angle side pair that we know. So we'll do sine of 92 over 41. And we'll say that equals sine of, let's see here, we want to find x. So we'll do sine of 45 because that's across from the x side that we're looking for. And then the side itself we'll just call x. Now to get x by itself, I need to cross multiply and then divide by sine of 92. So if I cross this way, I've got x equaling 41 times the sine of 45. And we would have x times sine of 92. But then I have to divide by the sine of 92. So ultimately, that ends up down here in the denominator. Okay, so now let's go ahead and just plug this in the calculator. So I did alpha y equals to get my fancy fraction, just so I can do all of this at once without worrying about PEMDAS. Pressing enter, that gives us 29.0 if we round to the nearest tenth. And since we found a side rather than an angle, law of sines has no ambiguity, and what you see is what you get. To find this missing angle for the triangle, since it's not a right triangle, but I do have an angle and a side that are across from each other that I know, I can use the law of sines. Sine of A over A equals sine of B over B. So let's start with the pair of angles and sides that I know. We'll do sine of 98 degrees over 16. And that's going to equal sine of x, that's the angle we're missing, over 12. Let's isolate sine of x as a first step to solving this. So just multiply by 12. So we have 12 sine of 98 over 16 equaling sine of x. And now to actually get x, we have to get rid of sine by taking sine inverse of everything. So let me do that on the calculator. So here I am on the calculator. I did second sine to get sine inverse, and alpha y equals to get my fancy fraction. Then I've got 12 sine of 98 over 16 in there. Pressing enter on all of that. That comes out to 47.96. So that's actually going to be 48.0 if I round to the nearest tenth. And that's an angle, so that's degrees. Now we have to be careful because law of sines doesn't always give you what you think it's giving you. Remember, you could have 0, 1, or 2 answers for these angles with law of sines. Well, obviously we have at least one answer. It's right here. But we have to check to see if the alternate answer to this would also work. So to get the other possible answer, we're going to do 180 minus 48, and that's going to give us 132 degrees, maybe. We actually have to check to see, though, if this fits in the triangle with the angle that we know they gave us. So 132 plus that original angle they gave us of 98, is that less, equal, or more than 180? Well, this is definitely going to be more than 180. I mean, you could add it up on the calculator. It actually comes out to, let's see here, this would be 230, I believe. It's more than 180. So that's really all we need to know for this. Since this can't fit in the same triangle as the angle that we know is in there, that means that 132 is actually a bad answer. We'll cross it off there, and then we'll just keep 48 as our only true answer. On this problem, I'm looking for this missing side of the triangle. Now, since I do have an angle and a side that are across from each other, I can use law of sines on this. Sine of A over A equals sine of B over B. Let's start with the pair that I know the most about. We have sine of 36 degrees over the opposite side from that, so 16. And that's going to equal sine of my other angle that I know, 113 degrees, over the side that I'm looking for that's across from that, x. Great. Well, let's isolate x. So if I multiply x over here and I cross multiply this way, I've got a 16 up here with the sine of 113, and this sine of 36 has to come back downstairs. We have to divide by that. So we've got all of this stuff over sine of 36. And now let's plug all that in the calculator. So here's what I did on my calculator. I did alpha y equals, and then again I have a 16 sine of 113 over sine of 36, and press enter. That gives us 25.1. So that's the length of this side. And since this is just a side and not an angle, law of sines has no ambiguity here. There's no alternate answer waiting for us. It's just 25.1, and that's it. On this problem, I'm trying to figure out this missing angle. Since this is not a right triangle necessarily, but I do have an angle and a side across from each other, I can use the law of sines. So sine of A over A equals sine of B over B. And then let me start with the angle side pair that I know the most about. So sine of 22 degrees over 17, and that's going to equal sine of that missing angle that we want, sine of x, over the side across from it, 19. Let's isolate sine of x. So to do that, we multiply by 19. That's 19 sine of 22 over 17. To actually get x, though, I need to take sine inverse of all this stuff. So let me do that on the calculator. On the calculator, I did second sine to get sine inverse, and I did alpha y equals to get my fancy fraction. Pressing enter on all that stuff comes out to 24.8 if I round up. And this is going to be a good answer for sure, but we might have an alternate answer as well that works. To get the other possible answer, we have to subtract this from 180. 180 minus 24.8, let's see here. Well, 180 minus 24, that would be 156, but this is going to be 0.8 less than that, so 155.2. There we go. So this is the other possibility. To see if it's actually going to work, though, we need to see what happens if I add this to the angle that's already in there. 155.2 plus 22, that's going to add up to 177.2, which doesn't really matter. What's important, though, is that it's less than 180. That means that this alternate answer will fit in the triangle, which means it is a legitimate answer. So both of these answers then, 24.8 and 155.2, are correct possibilities. For this problem, I'm looking for this missing angle. We don't know that this is a right triangle, but we do know a side and an angle that are opposite each other. So we can use the law of sines. Sine of A over A equals sine of B over B. So we've got sine of 65 over the side across from it, which was 28. And then we also have sine of x, the angle we're missing, over its opposite side, 27. Next, let's get sine of x by itself by multiplying by 27. So that's 27 sine of 65 over 28. And now to actually get x, I have to take sine inverse of all this craziness. Let me do that on the calculator. So on my calculator, I did second sine, and then alpha y equals gives me the fancy fraction. So we have 27 sine of 65 over 28, pressing enter. That's 60.9. And that is one possible answer. It's a good answer. We know for sure that this is at least one of the correct answers, but there might be another correct answer as well. To see, we have to subtract this from 180. You always have to do this with law of sines. So 180 minus that, let's see here. Well, 180 minus 61, that would be 119. So this is going to be, let me see, 119.1. There we go. Now the question is, does this answer also fit in the triangle with the angle they already gave us, the 65? If I do 119.1 plus 65, well, if we did just 120 plus 65, that would clearly be more than 180, and so is something that's 0.9 less than that. So since this comes out to something more than 180, that means that this alternate answer actually is not a possibility. We have to cross it off, which means that the only answer on this is actually just 60.9.